Arkadaşlar, in this video, I will try to solve very critical questions, and I hope you will understand how we approach to these kind of problems, okay? There are two questions on the board, as you can see on the screen. One of them is like, I'm giving you the input and the output here, and then I'm asking you if this system is causal and or stable, okay? This is the first question. This is a continuous time system. And then I have another system, which is discrete time in this question. And I'm still asking you if the system is causal and or stable or not, okay? These are the two questions that I want you to focus. Now, we approach to this problem like this, arkadaşlar. What is the system? How is the system characterized? My system is characterized by h of t. I don't look at x of t, arkadaşlar. I don't look at x of t. I just look at h of t for the causality or stability kind of problems, okay? So that's why we should focus on h of t and see what kind of a system is this. And then if you write minus t minus 1 greater than 0, and then I would like to plot right now u of minus t minus 1, and then minus t will be greater than 1, and t is less than minus 1, right? So how is my signal? It is something like this. So this is my h of t, and this is 1, and before minus 1, my signal is like that, okay? So I focus on this one. In terms of causality, bakın arkadaşlar, causality, I should check if h of t is equal to 0 for t less than 0. If you look at h of t, and if h of t is something like that, that means 0 before 0, then it is stable. But if I have something like that, okay, if there is something before 0, then I should say this is unstable, okay? Sorry, not stable, causal, I mean, okay? Let me draw this again. Let me draw this part again. Arkadaşlar, I look at my h of t. And if this is an example of h of t, which is, for example, 0 before 0, then I would say this is a causal system. If there is such a thing, let's say greater than minus 1, everything is 1, that means in this part, we have non-zero values. That means h of t is not 0 for t less than 0, right? So that means my system should be non-causal if that's the case. If you look at this part right now, what do we see? Do we see anything before 0? Yes. Before 0, we have h of t. So that means our system is non-causal, okay? So for causality, I check h of t, and if h of t is something different than 0 for t less than 0, for negative t values, then I would say this is a non-causal system, okay? So for the second question, I do the same thing. I don't look at this. I focus on h of n. For h of n, I do the same thing for me to practice h of n like that. For n plus 1 greater than 0, n should be greater than minus 1, okay? So for minus 1, it is 2. Then for 0, it is 1, 1 over 2, 1 over 4, This is -1, 0, 1, 2. This is n, okay? This is h of n. How do I check the stability and causality of this system? First, let us focus on the causality, just as we have done in the first question. I should check if h of n is 0 or not when n is less than 0, okay? So I should check if there is anything in this part of my signal. Yes, there is. So there is this component which cause the system to be non-causal. Okay. So if because h minus 1 is not equal to 0, my system is non-causal. Okay. I hope you got the main message. What are the two things that you should be careful about? If I'm asking if this system is stable or causal, I should only check h of n or h of t. Secondly, I will draw or look at the signal and see if there is any components that are less than 0 for the t or n values. If there is any value which is different than 0 for the t or n values that are less than 0, then I would say the system is non-causal, okay? For example, if my h of t is something like this, 1 or 2, 3, 4, then my system would be causal, okay? Let's continue with stability, arkadaşlar, okay? Now, I will focus on the same questions, but this time in terms of stability. For h of t is equal to, for h of t equal to u minus t minus 1, I should now check this. How do I check the stability, arkadaşlar? I should check this, okay? Integral from minus infinity to plus infinity, h of t dt. If this is less than infinity, that means if this is finite, if the integration of this system characteristics, which is like h of t, which is my impulse response. For the stability, I will again check h of t. And if h of t, you see from minus infinity to plus 1 dt, I check this, like I looked at this function, which is from minus infinity to minus 1, and the value over there is 1. So if I take t from minus infinity to minus 1, okay, which is equal to minus infinity. So let me remind you that this should be like infinite, okay, absolute value. So I should also check this, okay, for the values that are let's say, let's remove these, and then I would say minus infinity minus 1, and it is like minus infinity. If I take the infinite absolute value, it becomes infinite. So the integration of u of minus t minus 1 is always going to infinity. We have done this in the previous video. If we take the integral of this, it will start increasing like this, right? So as we go to the minus part, it will go to infinity. So the input is bounded, but the output is unbounded. So my system is unstable. Okay, I hope you get this point. Let me move to the next question. It was like h of n, 2 to the power, how was it? 1 over 2 to the power, 1 over 2 to the power, un plus 1. Okay, now again, I'm only looking at h of n for the stability check. And it's like, what do? I should now not integrate, but I should write a summation, infinite summation, 1 over 2 to the power n un h n plus 1 absolute value of this should be finite. Okay. If this is finite, then I would say my system is stable. If the output, if the absolute value of the summation is infinite, is converging to infinity, it means it is unstable. Okay. Let me do the calculations here. So this one is like from -1 to infinity, and I have 1/2 to the power n, and then it's like from 0 to infinity, 1/2 to power n plus 1. Now it is not from -1, it is now from 0 to infinity, right? So actually this is -1. It doesn't really affect our stability concept, but let me do it like this. M is equal to n plus 1, right? Then my summation variable will be -1 plus 1, which is 0. Infinity plus 1 is infinity. And I will write 1/2 to the power n is m minus 1, okay? So this becomes m minus 1. So it is like 1/2 to the power -1. M is equal to 0 to infinity, and then 1/2 to the power m, right? So we know that this converges to 2, this converges to 2, so my summation is 4, which is less than infinity, which is like a finite value. Then I would say my system is stable. Okay, I hope you get the main idea. This is very critical for you to understand that for the causality and stability, we should always look at h of t and h of n. Hope to see you in the next video.